Welcome to CubeWorks. Every water district in the Philippines reports non-revenue water, or NRW, as a percentage: 32%, 38%, 41%. This metric serves well for high-level benchmarking. However, a percentage is an abstraction that rarely carries the weight of currency. When a district's 38, a board may acknowledge a percentage in an annual report, but a massive liability appearing on the balance sheet demands a different level of scrutiny. We bridge this gap using a specific calculation designed to translate the NRW percentage into a comprehensive financial impact. This framework follows the International Water Association's economic level of leakage methodology and LWUA's water loss management guidelines, adapted specifically for the Philippine utility market. Run-in miscalculation provides the board with the actual peso value of the loss, shifting the debate from engineering metrics to fiscal responsibility. The true cost of non-revenue water consists of 5 distinct cumulative financial vectors. Component 1 is the production cost of the lost volume. Every cubic meter of NRW was treated and pumped at the district's expense without generating revenue. For surface water with conventional treatment, production costs range from 12 to 18 pesos per cubic meter. Groundwater runs between 6 and 10. Component 2 is foregone revenue. Had this been billed, it would have generated income. Average residential tariffs sit between 25 and 45 pesos per cubic meter, while commercial equivalents reach 65. These first two components represent the immediate cash the utility burns to produce the product and the revenue it fails to collect at the meter. The third component is accelerated infrastructure deterioration. Physical leaks saturate the surrounding soil, which destabilizes the pipe's bedding material and increases external loading. This constant moisture also accelerates external pipe wall corrosion and leads to pavement subsidence over time. Pipes in high leakage areas often have a service life 20 to 40% shorter than those in low leakage zones. This deterioration translates into an annualized capital cost penalty, often estimated at 5 to 10% of the total pipe replacement budget. Component 4 is the excess pumping energy. Delivering the required build volume through a system with 35% NRW requires pumping roughly 1.5 times more water than a tight system would. Physical leaks waste the water itself while simultaneously degrading the surrounding capital assets and inflating operational power requirements. The final layer represents environmental and social costs. While these are often ignored in internal reports, they represent inevitable deferred expenditures. Over-extraction driven by high NRW depletes aquifers. For water-stressed districts, the cost of developing and certifying a single new deep well can run between 2 and 8 million pesos. Social costs add further weight, including the economic impact of service interruptions, road damage from water infiltration, and the public health risks of contamination during pipe bursts. These externalities are not abstract concepts. They are the financial precursors to future capital outlays and regulatory liabilities. We can apply this to a medium-sized Philippine district. Input is 850,000 cubic meters per month at 35% NRW, with a 14 peso production cost. Component 1 totals 49.98 million pesos per year. Component 2, foregone revenue, adjusted for unbilled authorized consumption, comes to 111 million pesos. Component 3, an 8% deterioration penalty on an 8 million peso pipe replacement budget, adds 640,000 pesos. Component 4 is already accounted for in the 14 peso production cost for this specific case study. Component 5, the amortized cost of deferred well development plus burst-related social impacts, adds another 1.3 million pesos. The total annual cost of 35% NRW for this district is 162.9 million pesos. This reality stands in stark contrast to the 15 million peso maintenance expense typically found in a district's internal reporting. The final step is packaging these financial realities into a boardroom presentation. Slide 1 shows the gap between the current 35% NRW and the LWUA 20% benchmark. Reaching that benchmark represents 69.8 million pesos in annual recoverable value. Slide 2 presents the reduction roadmap, aiming for a move from 35 to 25% NRW over 36 months through targeted DMA monitoring and pressure management. Slide 3 requests the capital investment, 8.5 million pesos for hardware and priority rehabilitation. Slide 4 details the return on investment. The program yields a 2.2-month payback period and a 10-year ROI of 33 to 1. A board weighing an 8 million peso request against a 15 million peso maintenance line faces a difficult prioritization. Reframing that same request as a 33 to 1 recovery of lost value shifts the proposal into the category of high-yield financial opportunities. Water loss persists primarily as a failure of financial reporting, rather than a lack of technical expertise or available funding. Your action for this week is to run this 5-component calculation using your district's production and billing figures. Conservative estimates alone are enough to build the case. This concludes our water utility series. Next month, we move to the electric cooperatives to analyze the metrics of grid reliability, SAIDI and SAIFI. Properly valuing water is the fundamental prerequisite to protecting it. Thanks for joining us. See you next time.